Hi, ladies and gentlemen. This is Mr. Green, and this is President's Day. Woohoo! So you get the day off. Well, if I don't give you a Class Connect, or at least a recording for something here, there's some things you might be missing. So I'm going to work through several problems here, just like I would do in a Class Connect, and you can watch the recording as you go along. What are we looking at? We're looking at prisms and pyramids, PYRMIDS, and cylinders. And like I said, we're going to do surface area and volume, and that's the things we're going to be doing with each one of the different objects. Don't forget, you do poorly on a quiz, please make sure you go back and do quiz corrections on it. There's a corrections drop box you can submit those into, and you shouldn't have any problems with that. Due dates: 28 days after an item is due, it locks up and you can't get into it anymore, and the grade will be locked. So you miss an item, you get a 0 on it, you want to make corrections to it, do it. Get it done quickly because you don't want it to get a 0 out there and stay as a 0. So let's enough about that. So, finding surface area and volume. This is a pyramid. This is a prism. It does have a pointy edge over here. It does have a triangle on it, but it is a prism. Okay? The bases are the same in this situation. I have two bases, and I'll color them both yellow so that we can see them. There's a yellow triangle right here, and there's a yellow triangle right back over here. Those are the bases. They're separated by a common distance. That would be what the classical definition of what a prism is. Okay? So we're looking at a prism. So our formula for surface area of a prism is 2 times the area of the base plus the perimeter times the height. Okay? Well, we need to find that area of the base. So what we're going to look at here, base, it's a triangle. So I'm going to use 1/2 BH. That's the triangle formula, right? So that's going to be 1/2 of 4 times 3. That's going to be 6. I'm going to need the perimeter too, so that means I need to find this side right here. Using the Pythagorean theorem, I find that that side is a 5. So my perimeter is going to be 3 plus 4 is 7 plus 5 is 12. So I can now find surface area. Surface area is going to be 2 times 6 plus 12 times 8. That's 12 plus 96. That's 108 millimeters squared. We're talking about area. It has to be squared. Okay? So let's look at the volume. What do we need for volume? The formula for volume is the area of the base times the height. A little bit simpler formula in this situation. We already had the base. That was 6. We know the height. That's 8. 6 times 8 is 48. And we're looking at 48 millimeters cubed in this case. Cubic millimeters. Difference in the way that we calculate those. Okay, surface area and volume here. What are we looking at? Once again, we are looking at a prism. Okay, this happens to be what type of a shape down here? It's a trapezoid. Coloring it in yellow again. Okay, well, where's the other trapezoid? It's right over here. It's the base. These are the bases of this prism. You notice neither one of them are on the bottom. Bases don't necessarily have to be on the bottom. It happens to be the two sides that are the same shape. And that's why we call this one a trapezoidal prism. So let me, looking at our formula again, we've got surface area, and that's going to be equal to 2 times the base plus the perimeter times the height. Well, the base in this situation is the trapezoid, 1/2, base 1 plus base 2 times the height of the trapezoid. So in this situation, my base 1 is a 5, my base 2 is a 3. I'm adding those together. My height is a 3, and so I'll be getting 8 times 3, which is 24 divided by 2 is 12. So I got the area of the base. My perimeter is going to be 5 plus 3 is 8, plus 3 more is 11, plus 3 more is 14.6 feet. So I can find my surface area. It's going to be 2 times 12 plus 14.6 times 7. I'm not real good with my 14.6s, so I'm going to actually have my calculator here, and I'm going to say 2 times 12 plus 14.6 times 7, and I get 126.2 feet squared. Volume. Well, volume's the same thing. Area of the base times the height. So we're going to say 12 times 7. That's going to be 70 and 14. That's 84 feet cubic feet. 84 cubic feet. Fairly good sized trapezoidal prism. Okay? Moving forward. Prism has an equilateral triangle. Well, I'm just going to draw an equilateral triangle here. If I draw an equilateral triangle, we know that all the sides of the triangle are 12, right? But that doesn't help us. Triangle, we need to have the height here. We also know the thing about an equilateral triangle. All the angles are 60 degrees, right? That means if I divide it in half, I've got a 30, 60, 90 triangle. And this side over here, the height, is going to be the square root of 2 times 6. That's what the apothem, or the height, altitude of that triangle will be, because it's a 30, 60, 90 triangle. Remember, this is still a prism. So we're looking at a triangular prism here, like that, right? And it's got a height of 10 here. So how do I find the surface area? Surface area is going to be 2 times the base plus the perimeter times the height. The base in this situation is going to be 6 square roots of 2 times 12 divided by 2. And then I'll multiply that whole thing by 2. So those are going to cancel each other out. And 6 times 12 is 72 square roots of 2. Plus, my perimeter in this case is 36. And my height of the prism is 10. So that's plus 360. Now I can find this by using my little calculator here. 72 square roots of 2 equals plus 360. Is that what I had? 360? Yeah, 360. And I press enter on that, and I get 461. That's approximately 461 meters squared. My volume is going to be equal to 36 square roots of 2 times 10, or 360 times the square root of 2. Now, how did I get that? I mean, I did that real quick. I looked over here and I saw 6 times 12 divided by 2. 2 goes in the 12, gives me a 6. 6 times 6 is 36. That's where I got the 36 square roots of 2. Okay? Because I didn't need 2 bases this time. That 2 out here didn't cancel out anymore. So 36 square roots of 2 times 10 gives me 360 square roots of 2. So 360, I can't get to my 0. 360 square roots of 2, and I get 509. So this is approximately 509 meters cubed, cubic meters. Fairly big triangular prism. Okay, so we've looked at that. Now let's look at an application of what we would do with prisms. This is a spice container. What does a spice container look like? Well, it looks like a little rectangle like this. It's got holes in the top of it so the spices can come out. Down, a little thing like this. Probably made out of tin. Might be sitting in your mom's kitchen somewhere where she keeps spices in it, like her cumin or her red chili peppers or her minced garlic or something like that. Well, this is what it looks like. It's a right rectangular prism. It's 6 centimeters long, that'd be 6 this way. It's 3 centimeters wide, that's this way. And it's 8 centimeters tall. Now, Victor is creating a label. Well, what's a label? It's going to be the surface area around the outside, right? We're not going to count the two bases. So in this case, I'm going to do surface area, but I just want the lateral portion of it. So I'm not going to do the 2 times the bases. I'm going to do the perimeter times the height. Well, the perimeter is 9 times 2 is 18 times 8. That'd be 80 and 64. That'd be 144. Did I do that math right? Let's see here. 18 times 8 equals 144. 144 centimeters squared. So 144 square centimeters of paper, he could make a label to go around the outside of it. Okay? This one is a word problem that you could see sometimes. It says the volume of a gift box is 64 cubic inches. Well, if it's cube, that means all the dimensions are the same, right? So I've got x, x, and the depth here is x. Right? Like that. So all three of them are x. So what would be my volume? Volume is going to wind up being x cubed. But that's 64. There's a way on the calculator to take the cube root of 64. It's just like the square root, but it's the cube root of it, okay? And I'm going to show you that right now. What I'm going to do is I'm going to say 64, and I'm going to press the little arrow button here, and I want to raise it to the 1/3 power. 1/3 represents the cube root. If you raised it to the third power, that'd be multiplying it times 3, but raising it to the 1/3 is finding the cube root. And we see that the cube root in this situation is 4. So that means x is equal to 4. That means that's the dimension on all three sides. So they're asking, what is the area of the cardboard that is used to create the surface area? So that means we need to find the base, which would be 4 times 4, 16. We need to find the perimeter, which is going to be 16. Well, we got that easy enough. And so we would say 2 times 16 plus 16 times 4. Okay? I'm going to come over here and real quickly do 6 times 16. Where'd the 6 come from? 4 plus 2. Factored it out real quickly. 96 inches squared. So 96 square inches of surface area. Oh, what's the volume? Well, the volume in this situation is going to be 16 times 4. So let me multiply that out real quickly. 16 times 4. And what do I get? 64. B is asking, what is the volume, the surface area to volume ratio? What do? We take 96. We divide it by 64. And we reduce. Okay? 96 divided by 64. Hit enter. And because I'm lazy, math, number 1 for fractions, and turn it into a fraction for me, and it turns it into a fraction of 3/2. Getting a calculator lesson here too. C is an interesting question, and it's where I wanted to get to. It says, if all three of the dimensions of the box are enlarged by the same constant factor, what would happen to the value of the surface area to volume ratio? Well, I think the easiest way to show this is let's just say, what if the dimensions, it is a 4 right now, we added 1 onto it. So we would have a 5. My area, my base becomes 25. My perimeter is now 20. And so my surface area is now 50 plus 100, or 150. My volume is now 125. And so my surface area to volume ratio is 150 divided by 125. And going back to the calculator here, 150 divided by 125 is that number. Math, turn it into a fraction for me, please. That's 6 over 5. Wait a second. So if I increased it by 1, it becomes 6 over 5. What happens if I increased it by 2? 4 plus 2, that's 6. My base becomes 36, B. My perimeter becomes 24. My surface area is 2 times the base, 72. Surface area. 72 plus 24 times 6. I can't do that in my head. 72 plus 24 times 6. And I get 216. 216. My volume becomes 36 times 6. 36 times 6 is 216. And so what do we wind up with? My surface area to volume ratio is equal to, well, that's 1. 216 divided by 216. So my surface area to volume ratio decreases as I'm increasing by a constant number. And it's going to keep decreasing as I get bigger and bigger. Why is this happening? Well, I want you to notice what's happening to my surface area. It's not growing at the same rate as my volume is it? See, this 50 and then 72, that's causing it to be just a little bit smaller. That base and the perimeter times the height, it doesn't grow quite as quickly as the volume grows. And so it is going to get smaller and smaller and smaller and smaller. And what we will see is the surface area to volume ratio actually does something like that. It's kind of like a parabola going off to the edge out that way. But it's going to decrease as it gets closer and closer to 0. I'm sorry, it's going to decrease as the dimensions get bigger and bigger and bigger in that situation. Okay. Surface area and volume of a pyramid. Okay, so we're looking at a pyramid. We're wanting to find the surface area and the volume of it. Okay, so how do we find the surface area of a pyramid? Okay, I'm putting a P there for pyramid. Well, we remember there's only one base now, and we're going to be adding to that the lateral surface area. Well, in this particular case, the lateral surface area is real easy to find. What you're going to do is you're going to take 1/2, because it is a triangle, of the height, the slant height, I'm using an L there, times the side, or times the perimeter of the side of the base. Okay? So we're still having to find the same things as we did before. So let's find B, the area of the base. It's an 8 millimeter base. That'd make it a 64. 8 times 8, 64 meters squared. My perimeter is going to be 8 times 4 is 32 meters. And so my surface area of the pyramid is going to be the area of the base, 64, plus 32 times 10.77. Why? That is the slant height. That's the one I need to be using there. Okay? So let's look at that. See if I can't multiply that out with my calculator here. Move the calculator so I can see my numbers here. And I'll have 64 plus 32 times 10.77. Oops, I forgot the 1/2 there somewhere. Divided by 2. Okay? I forgot the 1/2 here. And what did I get as a number there? I got 236.32 meters squared. So let's figure out the volume in this situation. Okay, my formula for volume of a pyramid is 1/3 the area of the base times the height. Well, my area of my base was 64, and my height was 10 meters, and I'm going to take and divide that by 3. Now, you heard me pause there for a second. I almost picked this slant height here, but it's not that. It's this height over here. This height here is the one that you use for the volume of the pyramid. Okay? So I'm going to take 64 times 10 divided by 3. And what do I get? 213.3 meters cubed. That's the volume of that one. Okay? So important things to remember here. 1/2 slant height times perimeter. Okay? And you got to make a distinction between the perimeter and the slant height and the height of the pyramid, because they're two separate numbers there. Okay? Let's look at this one. We're going to do the same thing. We're going to find the surface area of this pyramid. So we want to find the area of the base plus 1/2 the slant height times the perimeter. And we want to find the volume, and that's going to be area of the base times the height divided by 3. Now, the only issue here is that my base is a triangle. And so what is the area of the base is going to be 1/2 times 20 times 17.32. That is the area of the base. So 20 times 17.32 divided by 2, and I get 173.2. So that's my base. What's my slant height in this situation? Well, they're showing it to me right here to be 30.55. So my surface area is going to be 173.2 plus 1/2 of 30.55 plus or times the perimeter, which is 3 times 2060. Okay? So that means, coming over here to the calculator, 30.55 times 60 divided by 2, and I get 916 and a half. 916 and a half. And I'm going to add that to 173.2, and I'm going to have 0.798 and 910. 180.97 meters squared. My volume, I'm going to take that same number for base, 173.2 times the height, which is 30 centimeters, divided by 30 meters divided by 3. Well, 30 and 3 go in, that's going to be a 10, so this is going to be 10732.0 meters cubed, and that would be my volume of that pyramid. 1,732 cubic meters. Okay? Moving forward. Damien's construction company is tiling the roof of a gazebo. The roof is in the shape of a regular hexagonal pyramid. Okay? With an open bottom. The side lengths of the hexagon base are 5 feet, and the slant height is 7 feet. So how do I find the surface area of the roof? Oh, they're asking, why is the surface area of the roof not equal to the surface area of a regular hexagonal pyramid with the same dimensions? And it's one word here. Open bottom. Right there, that open. We don't have a base on it, do we? We just have the lateral surface area on this particular roof. No base on it. Okay? So they want me to calculate the volume and the surface area. First of all, area of the base. The area of the base is 1/2 P times the apothem. Oh my. It's a hexagon and it's got a length of 5. That means my apothem is going to be 2.5. A is going to be equal to 2.5 square roots of 2. How did I know that? Well, it's one of those 30, 60, 90 triangles, and it's the small side is half of this number. Oh, you know what? Wrong. No, that's right. The apothem of the base is 2.5 square roots of 2. I did that right. Okay? And so the perimeter of this is going to be 6 times 5 is 30. So I'm going to have the area of the base is going to be 1 half times 30 times 2.5 square roots of 2. And once again, that 2.5 square roots of 2 came from a 30, 60, 90 triangle that I used the ratios of, with 5 being the smallest side, and I needed to find the longer side. So I've got 30 times 2.5 square roots, second, nope, back up, second square root of square root of 2 divide equals, oh, yeah, equals, I knew it was not going to work. Okay, let's try that again. 30 times 2.5 times second square root. It didn't like my square root there. Enter. And I'm going to take that and I'm going to divide the whole thing by 2, because that's what I have to do. And I get 53.03. We'll leave it at 53. So the area of the base is going to be approximately 53. So to find the surface area, and remember this one is lateral only, lateral surface area, I'm going to take 1 half of the slant height times the perimeter. My perimeter in this case is 30. My slant height is 7. That's what they're telling you right here. Slant height is 7 feet. And I'll take 1 half of that. So that's 7 times 15 is what that amounts to, because half of 30 is 15. So 15 times 7, and I wind up with 105. My total surface, my lateral surface area is 105. My volume in this situation is I'm going to use that 53 that I had, 53, and I need to find the height of the roof. Well, they didn't tell me the height of the roof, did they? What they gave me was the slant height. So looking at that, what you're actually looking for is you want to know the height of the roof. You know that the distance from here to there, do you know that? You know that distance is 7. That's the slant height, right? Do we know this distance here? Did they give us that? Oh yes, that's this 2.5 square roots of 2. So we can now use the Pythagorean theorem to find the height of the gazebo. 7 squared minus 2.5 square roots of 2. Like that. And we get an answer of 45.46. We need to take the square root of that. So second square root of that number right there, and we wind up with 6.7. So this height here is 6.7. So I'm going to be multiplying this times 6.7, dividing the whole thing by 3. So once again, leaving that number there, times 53 divided by 3, and I wind up with 119. So my volume is 119 meters, feet cubed, 119 cubic feet. Okay, moving forward here. This is a cylinder. The only difference in a cylinder and a prism is that we have a round object at the end, a circle. So if I looked at a surface area of a cylinder, I had 2 times the base plus the perimeter times the height. Well, we can do the exact same thing here. 2 times the base. Well, the base in this situation is pi r squared. And my perimeter in this situation is 2 pi r. And so that's the formula. And that's how we get the formula for surface area of a cylinder. Okay? So all we have to know is the radius, 18 millimeters, and we can plug it into this equation. 2 times pi times 18 squared plus 2 times pi times 18 times 34, which is the distance between them. Now I'm going to do something really strange here. 18 squared times 2 is 648. 648 pi plus, I'm going to take 18 times 34 times 2, and I get 1,224. 1,224 pi. I can add those together real easily. 8, 9, 10, 11, 12, carry your 1. That's 6, 7, and 8, 1872 pi. That is the surface area exactly. Okay? Now, at this point, I can take that number and uh, very easily multiply it times a value for pi. So I could multiply this times second plus, not plus, second up arrow. Clear. Take that number times second up arrow to get pi. And it sticks a little pi in there for me. And it multiplies it out, and it tells me that it's 581, 5881 approximately. And that's meters squared. Okay? Now, if you wanted to use 3.14, you would actually get a slightly different number. And this is where I wanted to show this to you. 1872 times 3.14, and I get a slightly different number. 5878. See, we're off here by 3, at least. Why are they different? Because I want to show you what this calculator uses for pi. A much bigger number here. This numbers out here became significant, didn't they? This is why you always solve it to get this exact answer here. Because some people might want to use 3.14, others might want to use 3.1415, others might want to use other values for pi. Okay? It could make a difference as to what you're using for your value of pi to figure out what you're going to be getting for an answer. So always leave your answer in terms of pi until the very end, and then multiply by whatever they told you to use. Okay? It will make a difference. Rounding errors do occur. If you multiply this out here by pi, you might get a slightly different number than what I'm going to get in here, and it could give you a rounding difference. Okay? Trying to be very specific about it. Okay, volume for a cylinder. Area of the base times the height. Same formula as it was in a prism. Not a problem here. Do we know the area of the base? Well, it's pi r squared. That's what the base is, times the height. So all I got to do is go to my calculator and say, oh, not that, calculator. Thank you. 18 squared times 34, and I will have 1,000 or 11,016. That is 11,016 pi. Pi, because there's a pi here still. That's my volume. And if I want to find an approximate number for that, I can then multiply it times 3.14 if that's what they're giving me to use for pi, and I wind up with 34,590. 90 meters cubed, cubic meters. And that's the volume of the cylinder. You're going, That is huge. Well, look at it. 34 meters long. That's 34 yards long. 18 meters as a radius. That's 36 meters high. That's almost 36. That's almost 36 yards high. That is a huge cylinder. Huge, huge cylinder laying on its side here. Okay? It's not like it's just a little oil drum. This is big. Okay, Yasmin is making strawberry jam, and she's storing the jam in glass jars. They are 3 inches in diameter and 4 inches in height. Okay, a jar looking like this. See, I can draw cylinders like this. My diameter across here is 3 inches. My height is 4 inches. And she wants to make labels to cover the entire surface area, the lateral surface area of each jar. Well, remember my surface area formula. It has 2 times the base plus the perimeter times the height. Well, we're not going to need this one because we don't want to have that. We want to have this over here. Well, that's 2 pi r times the h. R in this case is, oh, they didn't give me r. They gave me diameter. So it's 1.5. Times 2 is 3. Times 4 is 12. I got 12 pi is my surface area. Well, you know what? She's going to want that in some number. So I'm going to say 12 times 3.14. And we wind up with, come on, 37.68 inches squared. That's how big each label must be. 37.68 inches. Square inches. Okay. A mailbox. Oh my goodness, a mailbox is shaped like a rectangular prism topped by half a cylinder. Where did you see a rectangular prism? Well, if I draw a line from here back to here and from here across, I think you can see the bottom down here and here in yellow is a prism. That's nice. Well, we're going to use a prism and a cylinder. We're going to use both formulas here, okay? So this dimension down here is 12. This dimension here is 4. This dimension here is 4. Okay? And my radius here is going to be half of that. It's going to be 2. Okay? So let's find the entire surface area. So in this case, my surface area of a prism comes into play, but we're only going to have one base because there's only a bottom. There's not a top on that prism. So I'm going to have one base plus the perimeter times the height. Well, in this case, 12 by 4, that's 48, plus 12 and 4 is 16, times 2 is 32, times the height is 4. So let's see here, that's 128. So that's 48 plus 128, 8 and 8 are 16, carrier 1, 76, 176. That's the prism. Now the cylinder on top, surface area of that cylinder on top, we actually want to take half a cylinder, don't we? But we'll look at that in a second. It's the area of the base, 2 times the area of the base, plus the perimeter times the height. Well, I only want to take half of this, so we'll divide it by 2 when we're done, because it's half a cylinder. Okay? Does that make sense? Okay. My base has got a 2-inch radius, so I'm going to come over here and say B is equal to pi r squared, and r in this case is a 2, so that's going to be 4 pi. Okay, and I'm going to have 2 times that, which is times 2 is 8 pi. Okay, so my surface area is going to be equal to 8 pi plus my perimeter in this situation is 2 pi r. That's going to be 4 pi. Once again, the same number times the height, which is 12, times 12 is going to be 48 pi. And add those together and I get 56 pi. So my surface area divided by 2 is going to be 2528 pi. Now I can multiply that times pi, and I just don't know my 3.14s all that well. So 28 times 3.14, and you get 283.14. Okay? So now I need to add those two numbers together. 176 and 283.14. And what do you get? 14, 9, 7, 7, 14, 15, carry your 1, and you get 459.14 inches squared. Cool? Okay, you can see what I did there is I found the area of the prism first. Okay, 5 sides. Okay, one base, perimeter, the lateral surface area here. And then I found the surface area of the cylinder. Okay, and I used the equations for that. 48, and I got 56 pi, but I only wanted half of the cylinder, so I divided it by 2 and got 28 pi. And when I multiplied that out, 28 times 3 is not 283. Where did I get that from? 28 times 3.14. 87.92. Wow. Why didn't you stop me on that one? 87.92. And then I take 176 plus 87.92 and add those together. 9, 2, 6, 6 or 12, 13, carry your 1, 16, carry your 1, 263.92 meters squared. Okay, better number. Sorry. Guys should have stopped me on that one. Oh, there's no one in the room. Sorry. Okay, that's why you didn't stop me. Okay. What did I multiply by to get that in the first place? 12. No. I had 37.68. It was in my calculator. I don't know what I was thinking there. Oh, I left the decimal place out. That's what it was. Yeah, I just left the multiply sign out there. Makes a huge difference. Okay, figured out what I did wrong there. One more problem, then we'll go on. I've got a cube here, and we cut out a cylinder out of the middle of it. First of all, we want to find volume information. So of the cube, the volume of the cube is going to be 8 to the third power. So let's just multiply that out real quickly and say 8 to the third power, and we get 512. Okay, so we need to find the volume of the cylinder. The volume of that's cube. The volume of the cylinder is going to be area of the base, which is pi r squared times the height. All right. Well, in this situation, my r is 2, so that's going to be 4 pi times 8. 8 times 4 is 32. 32 pi. So my cylinder's volume in this situation is going to be 32 times 3.14, and I wound up with 100.48. And what has happened? We have a cube with a cylinder drilled out. So what I need to do is subtract it. 512 minus 100.48. And what do I get when I do that? 1, 1, 4. 411.52 centimeters cube. That would be the remaining volume. Okay? So let's remember. Oh, wait a second. There's one more here. Sorry. Drinking straw, 1 centimeter in diameter. That's here. That's 1 centimeter. Okay? 15 centimeters long. Really long centimeters here. Another circle down here. Really long. Cylinder. It's a really long cylinder, isn't it? What is the volume? Well, pi r squared times the height. In this case, it's a diameter, so we have to use half of that. So it is 0.5 squared times 15 times pi. So I'm going to do that first part of it first. 0.5 squared, and I'll get clear. 0.5 squared, and I'll get 0.25 times 15, and I get 3.75. So I will multiply that times 3.14, last thing, and I get 11.775 centimeters cubed. That is exactly what the volume of a straw is. Nearly, approximately 12 centimeters cubed. Okay? Okay, secret word for today is space. So if you're watching this video, either Monday, Tuesday, whenever you get a chance to watch it, send me the word space and the fact that you're in geometry, and I will give you credit for having watched the recording, okay? These are the teaks that we've been covering, and I want you to notice right here, it says find surface area and volumes of prisms, spheres, and cones, and cylinders. That's what we've been doing. And guess what? Composite figures. That's exactly what we were doing with the mailbox, is a composite figure. And we're going to analyze the characteristics of polyhedra and other three-dimensional figures and component based upon explorations in concrete models. That's what we did with that cube when we were taking the dimensions and figuring out if the dimensions changed, what it did to the surface area volume ratio. Okay? And we're also looking at the effect of on perimeter, area, volume, and one or more dimensions of a figure are changed. That's what we've been looking at there. Okay? So we were working problems just like almost all of these. Okay? We're doing this. We are doing the things we need to be doing to accomplish the teaks. Cool. Okay. Don't forget, tell me you're in geometry if you send me emails. It really helps me to figure out what's going on, okay? And I'm the one who's lost if I don't get it. I appreciate it, and I will talk to you at the next Class Connect.